platinum keynote address on accelerating business transformation. Please welcome up from Intel, Takashi Tokinaga.
Close enough. Hi, thank you. I hope you enjoyed the video because I really like this video a lot because it's kind of funny and I'm the guy that's sitting in the middle of your lunch and the presentation itself. So I figured that I wanted to give you something exciting to share. But I also like this video because it shows the importance of the enterprise itself. A little bit about me. My name is Takashi. I'm based in Singapore, and I manage the B2B marketing for the Intel, Asia Pacific and Japan region itself. I've been with the industry over 20 years, and the entire my life has been focused on the B2B audience itself. Prior to joining Intel, I was actually on your side, IT delivery side. When I actually joined the industry 20 plus years ago, one of my first projects I was involved is to do a mainframe to open path migration itself. 20 plus years ago, mainframe had the life cycle of the 10 plus years. So one of the key projects I was originally involved in is to migrate off from the mainframe, which we were using like $1 million a year to manage the system itself, which nobody wanted to pay for. So it took me 3 years to migrate, plan for it, size it, do the migration, do the testing, in order to migrate from the mainframe that we used for the 10 years into the open platform itself. That was 20 years ago. I still remember I was personally involved in it. Circle that back into after 10 plus years. One of the key projects I was personally involved, roughly around the year 2000, was to introduce the system that you're able to order a phone over the internet in Singapore. So you go to the online, you order the phone, and the next day the phone will be delivered to you, activated. So original system I did 20 years ago, mainframe migration, which we used for the 10 years, which took me 3 years to migrate. After 10 years, one of the key projects I was personally involved in to be able to order a phone, that system only took me 6 months to build it. So it's a quite fast-pacing industry itself. And what I wanted to talk today, the theme of the event is to optimize your enterprise. And as a technology company, I first like to say thanks for our friends over there for giving us a spot. And I equally wanted to appreciate the time we're spending for the next 30 minutes to discuss, okay, as a technology company, what are we doing? What are we doing to help you optimize your enterprise? So that's the theme of our event and my message today. I noticed that there's a few representatives outside of the South Asia today. So what I have done is I mapped all the IT spendings. IT spendings include the software, services, hardware, anything that's related to IT is bundled into this blue bar. So blue bar represents all the numbers of the IT spending growth in this part of the Asia itself. It includes Japan, it includes China, it includes ANZ, Southeast Asia, South Asia, including India, Pakistan, Bangladesh, which is the blue bar. Good news for the IT company like us, the numbers are growing. Now, if you have to look at the green bar, that's also presents a higher challenge to the audience here, because the green bar represents the growth of the Southeast Asia IT spendings. And if you look at the Pakistan, Bangladesh, and India, number will become even higher. What this means is that you face one of the hardest challenges in the industry. That your expectation is going faster than the rest of the Asia. Your pressure you get from the customer is much higher than anybody you face on the rest of the world, including knowing the fact that Asia is one of the fastest growth industry itself, and you belong to one of the fastest growth industry on the planet, which presents the highest challenge I can think of, because I know for the fact that your IT spending doesn't go up double digits each year. Your technology and challenge and complexity you face just multiplies it each year. There's something you do, like a mainframe days, you plan for it, you size it, you take 3 years to build a new system itself. Nowadays, I haven't met any customer who has the luxury to be able to size it, test it, and plan for it for the one new system to deploy for the next 3 years. It's impossible. We don't live in that age, and this number tells us that we face one of the biggest challenges of the industry. And as a technology company, we need to be able to give you solutions and technology to offer that. Because we know that we now live in the industry, what we call the digital service economy. My personal example, I'm based in Singapore. So over the weekend, I went to the online, booked my ticket online. Last night, before I departed my home, I used my smartphone to call my taxi. So I went to the Changi airport. And anybody who went to the Changi airport, you don't actually talk to human being to check in. You go to the airport, you show the print out of your check-in, or in my case, I show my phone to show that I'm checking into the airplane. I go to the customs, I do my swipe to my passport in, I go to the check-in counters, and there you go. I just checked in without even have to talk to one single human being. Now I arrived at KL, and I texted my friends in KL to pick me up using a WhatsApp. I again arrived in Malaysia, checked in, I said hi to the custom people. Too bad he didn't even say hi back to me. So I did my fingerprinting online. I got out from the customs, I picked my luggage, I went to the kiosk to the express train to the central area. Again, I texted my friend in the KL to pick me up. All of this, I noticed, oh, wait a minute, I didn't even talk to one single human being, except that I say hi to this gentleman in the custom when they reply to me. So it's kind of interesting environment. We face the environment that the digital services economy, you face the customer, you don't really meet the customer face to face. No matter which industry you're in, who the customer is, you face the situation that the industry is moving this way. It's also adds a challenge to the people like us because we don't really meet the customer. Therefore, it's very difficult to forecast the challenge and demand that you don't really know when your next customer comes up. You may all of a sudden become very popular in the social media and your system's workload just goes spike up. And it's difficult to forecast because we are living in a digital economy. And that requires a different challenge to optimize your enterprise and make sure that your infrastructure is ready to support that. So for us, digital service economy means a few things. And what this means to the data center people, it needs to be a scalable system. It needs to be able to scale on demand. And it goes with the consistent to all the keynotes we heard. System and infrastructure needs to be very, very scalable. Which is easy to say how to do. Because how do you make your system to be scalable without even knowing, would I be serving 100 people, or 1,000 people, 1 million people? It's easy to say, but it's difficult to forecast. What does this mean for us? At the same time, we also understand that your system, you don't have a luxury of having a double-digit growth of your IT spendings each year. So that your system needs to be efficient, low-cost operations itself. You do not get to hire the hundreds of people to manage your server migrations anymore. In the first job, mainframe project, which I was involved in, that took me 3 years to plan it, the entire teams to support it was 150. I was one of them. I don't think today, if I were to come back to the customer saying, hey, let's do your migration, you need to pay me 150 headcount. People will probably throw me out of the windows, because today that ain't gonna work. And it's also important to the consistent to the message we have from the Bob in prior to my speech is that your system needs to be very, very consistent. That's one key thing that the Dell and Intel community share. Because you cannot just afford to pay for the proprietary solutions anymore. Proprietary solutions do not give you flexibility, and the proprietary solution is very expensive to manage. We totally believe in the simple IT with the consistent service delivery, because consistency will give you a speed and agility and the cost per performance you need. So that we totally share this vision with Dell over the 20 years, and we continue to do so. Now, let me go a little bit more into the system itself, because we also heard that we heard a lot of people talking about the software-defined infrastructure this morning. And I'm also talking about the software-defined infrastructure itself. From the Intel's point of view, software-defined infrastructure actually means 3 different things we need to look into as a technology company. First of all, your service needs to be adaptable. You cannot just size it to expect the customer to behave the way that you size it. So that your systems and services needs to be very agile, and it needs to be adaptable. And somewhere in the middle, you see something called orchestration software. But your system also needs to be able to cater for different workloads. Your workload may be high on the ERP at the end of the year, we're doing some calculations itself. Your workload on the email is maybe high. Next month, your marketing group is doing some mass marketing itself. You cannot just size the system in a way in the boxes itself. You need to make sure that you orchestrate the infrastructure and you should have a power to be able to do so. In my old days, I needed to talk to my storage guy, network guy, server guy, OS guy, backup guy, security guy, in order to get one system in one conjunctions. Look how many meetings we have to go through in order to just define what we need to do, let alone thinking about the test patterns and all these things we needed to do. We cannot do that anymore. It needs to be, that's why what I mean by the orchestration itself, because you should have a total power without have to beg to your storage guy, network guy, server guy, OS guy in order to scope for the system that you need to build. And most importantly, on the bottom, it says resource pool. Today, like my example, storage, network, compute, which includes servers, may not necessarily do a good job talking to each other. You may have to use 3 different reports in order to understand how your system workload is going, which is not great. You need to have a total control over your resources itself as one single bucket, rather than okay, I have this much space in the storage, I have this much workload on the network, and my server utilization is 20%. You cannot be able to do that because you need to have a total control. And as a technology company, that's what we're trying to do. So when we say software-defined infrastructure, what this really means to you is that we're trying to empower the capability so that you have a total control over the infrastructure itself. And I get the fact that we're not there yet. So there's a lot of things that as a technology company we need to go forward with, but that's our vision, and that's where we want to go. And it's also funny, because Intel, as you know, is a CPU. We're known for the technology. We're known for the chip. So why would you think that Intel is talking about the software-defined infrastructure? Well, if you look at all the stuff you have in the data center, starting for the servers and the storages and network itself, you've heard the wonderful video that the data center dependency, once everything plugs off, your whole system shuts down. Not an infrastructure today runs based on the Intel architecture. So as a technology company, we feel it's our commitment and obligation to make sure that you have the power, because we are the technology company. We're the company that's empowering a data center across the board. So as a technology company, we need to come up with a technology in order to serve and meet your needs. So that's what we're trying to do. And I'd like to spend a little bit more time going into the details. So I started this speech by talking my personal example 20 years ago that I spent 3 years just to migrate off from the mainframes to the open platform itself. Now, your customer, nor your divisions, or whoever you're serving, the customers internally or externally, they're not going to wait 3 years for the system to come up. They are talking about the seconds, not even the months, which is kind of scary. So, because today, Intel, we have 100,000 employees. Guess how many server boxes we have? We have more servers than our employees in itself. Today, our IT roughly takes 2 to 3 weeks to bring a new system out. Because if you look at our CPU, which consists of anywhere between 20 to 30 transistors itself, it's impossible to design the system on your hands and pencils. We need a computer to design and empower our own business itself. That's why we have more servers than our people in the company itself. Today, the 2 to 3 weeks is not too bad considering industry benchmark, but we're trying to go into the days to the hours itself. So we are eating our own dog food because we know that your pains and our technology is not there yet. And we are now adding another capability in order to meet it. So traditional Intel's messaging, each time we talk about the new products and technology, it's all about the performance. It's 2x faster than last year's product. That's technically what you heard us speak about. But what we're trying to do is something very different, because we're now looking at the entire data center from the network to the storages and the servers itself. And we know we need to optimize across the board. And we need to provide the technology in partnership with a company like Dell to meet your needs. So that's sort of the one area that Intel is very, very excited. We want to turn your system from the static system, just like a mainframe example I used, into the very, very dynamic environment. We want to make sure that you don't have to do another manual spanning and manual coding. It needs to be automated. You don't have hundreds of the people who looks over the storage and networks and servers anymore. The system needs to be automated. And the technology is getting there. And we have a few different examples I wanted to show today. So today, I'd like to introduce to you is what we call the foundation of the software-defined infrastructure itself. Because as a technology company, we've done a lot of work in order to make the needs of the things we just talked about. Today, I know that excuse me for a moment. You don't really get to see this because the stage is so big, but this is a new CPU we just launched about a month ago. It's called Xeon Processor E5000 version 3. It's fresh out from the suite, and you'll probably hear from the demo in the later part of the session itself. But we're very excited about the technology, not because it's a new product, and we just hit the 27 world record on the performance part of it, but we're also excited that we put a lot of technology into it to make sure that we meet the performance needs we need, because Intel's new product always delivers the best energy efficient performance on the planet. But we also wanted to put another designs and the technology into it to provide a common architecture, not just for the storage itself, not just for the network, and not just for the servers, but a common architecture to support your data center need. And the last, more importantly, since if you were to look at your data center, there's a lot of components powered by the Intel today. So we put a lot of efforts to put the monitoring and the control capability to give the control back to you. So those are some of the exciting technology we have embedded into the system itself. So this is it. Now, I mentioned that we have broken 27 world record, which makes this server CPU one of the fastest CPU we ever introduced, which also is the most energy efficient part of the platform that we are providing into the data center. And there's a cool technology we've done with Dell. So I want to cover that in the later part of the session. But it also supports all the world live data benchmark itself. So when I say 27 world record, it's a spec, TPCs, and all these performance benchmark. And some people told us, hey, that's a very synthetic benchmark. So we do have a live example of how it delivers the different needs of the systems and the capability you're looking for. Starts from the cloud data with big data, which delivers one of the best performance that they've ever seen before, which empowers you to do more things that you're not able to do today, including life science to the finance to the manufacturing telecommunications itself. So we have catered for the different workloads needs to support the different requirements you have. So that's one. Performance is totally awesome, and we're super excited to be able to introduce that to you today. Another thing is that I mentioned this before, but we're now providing a common architecture between the compute, storage, and network itself. So if you were to go to the showcase next after this, you'll see different platforms being offered through Dell, which you may see an Intel's logo next to it, because we worked behind the scenes in order to make sure that we provide open and common architecture to you. So that's another exciting thing we've done in partnerships with Dell itself. And we started today's session by having this exciting demo with the Formula 1 racing. And Intel also likes to talk about the Formula 1 racing, because we believe that our technology, especially our CPU platform, is like an engine. So if you're into the motorsports, you're not going to purchase the Formula 1 race systems by putting a chassis, the hardware itself, and you're not going to put the compact car engine into it. Vice versa, you're not going to buy a Formula 1 style engine and put it on top of the compact car itself, because you're probably not going to run very fast. So we needed to provide a lot of technology and architecture to optimize across this different system itself. One of which is the transitioning into the DDR4 memory itself. Because if your engine is running faster, your foot also needs to run faster too. So in order to optimize it, we needed to change a few things into the architecture to support the engine, which is one of the fastest on the planet right now. We also added a lot of capability from the CPU to the network to the storage itself. So it will accelerate all the transition itself, because you cannot just have one very fast CPU running very fast, and the storage and network not meeting the demands and the speed itself. So we needed to deploy the technology to make sure that if our architecture and CPU is running very fast, we needed to make sure our network and storage also gives a path to adapt the needs of the system that's running the highest performance capability possible. We also added some of the capability to give you a control into the system. So you see a few different code out with the development kits and library. What we've done is that we added the capability into the system to allow you to control and monitor the system that you never actually had before, which is one of the key foundations of why we believe in the software-defined infrastructure. And as a technology company, some of the changes we deploy into the system itself. And one of the key attributes itself, and this is actually based on your feedback. We got few people to provide us a feedback. Hey, Intel, okay, I get you what you do. You provide the CPU to the server side, power edge on the system like that. Guess what happens? I have a storage system, I have a network system, I have a server system. I get different reports from the different hardware itself because they don't usually talk to each other. If my storage says my performance is high, what is that? If my server says my temperature is very high, what is that? What should I do? Is it high because the server is super hot? Or is it high because there's something wrong with the storage or the network? Today, we don't have a good interface to all different components of the data center, which we needed to enable some of the capability into it. So that when you get a report from your data center, not just the box, but the data center itself, you should have a control visibility onto the power, performance, security, thermostats, and all these things as one consistent information you get so that you have a total control over your data center. Something we didn't do a good job before, because you may end up using a different hardware and solutions in itself, but since we provide a foundation of the technology itself, well, that's what we try to do. We provide some of the interfaces and capability into the system so that when you get the workloads out from the servers or the storage or the network itself, you get a consistent information across the board, which is kind of exciting if you're into the system management kind of thing, like me. But this is also a capability we added. And here's some of the cool examples. As a technology company, and since I work for the Intel, I sometimes get questions like, hey, Intel, your x86. It doesn't really matter. Doesn't really matter that should I buy a platform for the Dell, or should I buy it from something else? We get questions like that. They ask us questions that, hey, why should I actually choose one company over another choice? Because it's x86. It runs everything on top. Answer is incorrect. Incorrect in the means that, especially if I were to pick on the power management capability, between Dell and Intel, Dell provides one of the most finest and the greatest energy management control that we have, because we worked with Dell and a few other companies in order to provide the hardware level power management. What this means is that if you were to look into the server or the storage or the network, CPU happens to be, I don't like this comment, but it happens to be one of the most hot components of the system itself. So in order to manage the entire system, we needed to provide a good capability into the hardware to give the information back to the system, either the storage or network or the servers, about how hot is this, what is happening, what is the system behaving now. And it kind of makes sense, because if you were to look into the hardware layer, there's a CPU, there's a memories and chipsets and all these hardware components, there's an OS, and there's a systems, and there's a data center on top of it. So if I can give a best fine detailed power management control from one of the hardest components of the system, it should allow the system to get you a better power management capability. So that if you happen to be looking into the next generation server systems deployment, please talk to whoever supplying your systems, what kind of power management capability does this hardware provide. And you'll be quite surprised that between Dell and Intel, we provide one of the best power management capability on your system on the planet. And also, one of the key thinking here, some of you, I met some of you before, but there are some of you, IT belongs to different groups to the facility itself. So as an IT group, you look at all the spendings of the IT services, software, hardware costs, maintenance costs, refresh cycles and stuff. But you may not necessarily look into the energy of the data center, which is equally important, and it's equally expensive too. So that if you do manage both, and if you haven't checked yourself, when you go back to your company itself, please take a time and take a look at how much energy costs you're spending to manage your data center. And you'll be quite surprised that it's very, very expensive. That's why we believe in the energy efficiency is one of the key things you need to look at. And you'll be saving a whole bunch of money by looking at not just how many servers units you have or how many people you got assigned to manage your system, but how much energy are you spending to manage your data center. And how can you save it? By moving into the more optimized enterprise environment. because energy cost happens to be anywhere between the 20 to 30% of your entire facility cost itself. And it's one of the most expensive one here in these regions. So you better check yourself if you haven't done it yet. Because we put a lot of capability into the systems in partnership with companies like DEFKL to make sure that you get the best of the energy efficient platform on the planet itself. So that's one key request I have. Please go back and check your energy cost of your data center, because you'll be quite surprised how much money you are able to save. And also, just raise of the hand, and I'm just curious questions. How many of you have some system virtualized today? Can you raise your hand? Okay, I see like 30, 20, 10% of people. Does it really mean that you're just shy, or that you don't really have any system that's virtualized? And in the industry reports from the IDC is concerned, it's difficult to say which one is not. But roughly speaking, in this industry, roughly we believe that there's 40 to 50% of the systems on the data center is virtualized. Obviously, the web servers and the light application is totally virtualized by now, and your database and backend system is maybe not. But in the roughly speaking, if you get to look at all the system in your system, it's probably more likely your server is virtualized anywhere between 30 to 40 to 50%. Your storage may not be, and your network may not be. And we're trying to give you a capability to be able to virtualize all the servers and storage and network itself. This is one good example if you actually manage your system on the virtualized environment. Historically speaking, let's say you have one system which serves different needs. And all of a sudden, your marketing department started to do some marketing promotions, which spiked up to one of the workload. The historical issue we have in this environment is what we call the noisy neighborhood issue. That you see this in the picture that there's a VM number 4 spiking up. So all of a sudden, your different department, your IT department, your procurement department, your finance department started saying, hey, what's going on? My system is very slow. Not because your server is not meeting a need, but you have this issue called a noisy neighborhood issue, that one of your system is eating up all the server resources itself. It's not just one server, but it could be one big data center itself. But if you have this noisy neighborhood issue, then your entire data center performance sucks, because it's just driven by the one workload itself. And it's been historically some of the issues that we face in the virtualized environment, and we know. So that we introduced some of the interesting technology to allow the system to be monitored. And the good news, we're working with some of the leading edge industry players such as VMware, Red Hat, or the Microsoft itself, in order to make sure our technology is something that looks nice on the PowerPoint, but you don't know how to use it. But we are working behind the scenes so that you don't really have to think that, hey, there's somebody from Intel mentioned this noisy neighborhood issue, but we're actually working behind the scenes with the key industry leaders to provide the technology so that you don't have to care about this. But it's one of the key components of the things that you may need to consider when you go into the virtualized environment, is that if one system is eating up the rest of your system workload, the system needs to be smart enough to tell you that, hey, this one is eating another chunk of my workload, can you do something about it? And it also needs to be intelligent enough or automated enough to split the workloads into the different VMs, because, hey, they got open systems, so that the system should be intelligent enough to offload some of the workloads to the different system, so it doesn't suck up all the system resources. So that's the one geeky technology I wanted to introduce today. I know that one of the representatives from the Intel will be presenting if you're into the technology things, tomorrow session we'll be talking about more about these insights, that it's exciting technology. I'm personally excited since I work for the Intel, but we're fixing a lot of issues behind the scenes, and our idea is to, just like Dell, our idea is to make it as simple as possible, so you don't really have to think about all these technology details. You should be as simple as click the button, and you should be able to do all the automations, all the workload balancing yourself. Today, we know it's not that, we're not there yet. So we are adding that capability to make sure that your system meets your needs and the services that you need, because we believe in the fact that we live in the digital economy. And the digital economy cannot be you spend 3 months planning for the next systems. Again, it needs to be as automated and as efficient as possible itself. Sounds good? I see a few people nodding their head, so thank you. So Two more slides. One, I'm very excited today that we're introducing a new platform. As with any of the new Intel technology itself, this one, the Xeon E5 version 3, provides up to the 3x performance itself. So first of all, is it a good product? Yeah, it's a good product. But it also provides the common architecture to your infrastructure. So that's one key thing that we wanted to walk away today. It's not just the server, the CPU that goes into your server anymore. It's the systems and architecture. It may go into your network and storage at the same time. So if you're thinking about your next generation platform itself, please ask yourself a question, just like what we heard from this morning, that is your system proprietary? Is your system simple enough to get you what you need and when you need it? If answer is no, I strongly suggest to talk to your friends over the Dell itself, because we put a lot of effort to make the technology simple and as agile as possible itself. And please also ask yourself, remembering that energy cost questions, how much do you know about your system? Not just the one component or the one hardware itself, but how much control do you have for the entire data center itself? Because have you seen the video? If the one light switch goes off, your whole system goes off is not a good thing. You need to know what's wrong with your system, and it cannot be just open up the 10 different applications to see what's going on. It needs to be simple enough to give you a dashboard to understand what are the issues are, and it should be as simple as click on the button to put the work to fix the issues itself. We're not there yet, but we're trying to get there. So that's one of the key things that the Intel is putting efforts to, in partnership with the Dell, to make sure that we provide one of the best architecture on the planet. And in order to do so, we need to make sure that your infrastructure stays simple and agile as possible. And that's one key thing that we believe in partnership with the Dell. Last slide, we are very excited. It's not just one event. I happen to be on stage talking to you today, sharing 30 minutes of your time. But it's over 20 years of the innovations with Dell. From the first generation of the system that Dell introduced, I think it's back in 1984, if I'm not mistaken, 1994, if I'm not mistaken. But from the day one when we started delivering a product itself, we believe and we continue to invest on the innovations itself, because we believe in the architecture that the system needs to be very simple. And you see a commitment in the very long words, but we're now taking this technology and the commitment, starting from the server side, put it into the storage side, put it into the network side, and making sure your data center stays simple and optimized as based on today's theme itself. And that's the end of my session today. Thank you for your patience. I hope wonderful lunch is waiting for you. And that's it. Thank you very much.
Thank you so much, Takashi from Intel. I hope you guys gained some insight there. Well, ladies